Hi, let's solve this mixing number problem. So the question goes like this. Given an array of numbers containing n distinct numbers in the range 0 to n, return the only number in the range that is missing from the array. So if you consider array as 1, 3, 0 and 1, so the number over here which is missing is 2. So basically like we need to consider 0 to n as the range and inclusive of n, and the number which is missing we need to return that. Like which is missing from that range, we need to return that. In this case, is it 2? It is 2. And if you consider 0 comma 1, the array length is 2, so the range would be 0 to 2, 0, 1 and 2, and the 2 is missing, so the answer is 2. And here 8 is missing, so 0 to 9, the array size is 9, so 0 to 9 and 8 is missing, so we need to return that. So there are multiple ways to solve this question. So the first solution that comes to my mind is sorting. So the approach is like we'll first sort the array and then we just check every index, and like if the element present at the respective index is same as the index itself. So if it is different, we are going to return that index. So after sorting, we'll just check if the element has 0th element would be 0 or not. After sorting, it would be 0 and the first would be 1, but the second would be 3. So we're going to return the second 2, basically the index. So array sort of nums for int equal to 0 is less than nums dot length I plus plus. If nums of I not equal to I, we're going to return I. And like in this case, if you consider this case, so 0 is present with respect to index, 1 is present with respect to index, so the missing number would be 2 because the range is from 0 to 2, from 0 to n. So return nums dot length. So like if the array is not if the like function is not returned from over here, it will just come over here and then you will just return from here. There's no need of else. Yeah, but the time complexity is order of n log n because the sorting takes order of n log n time, and the space is order of n, so that doesn't affect. So we can think of better solutions than this. So other solution would be using an hash set which takes order of n time but order of n space. So what we are going to do is we are going to traverse through the array and all the elements to the hash set, and then we are going to just check if all the n numbers are present. If any number is missing, we are just going to return that. So hash set integer set equal to new hash set for int I equal to 0, I is less than nums dot length I plus plus set dot add of nums of I. Now we are just going to traverse through the array and we are just going to check if all the numbers are present. Now we need to go up to nums dot length, like we need to include this also, n also, array size basically. If set dot contains of I double equal to false, I mean if it doesn't contain that, we are going to return I and return -1 if all the elements are present. I mean this case is will never come, but the ID like read code will show us error if we don't have a return statement here. Yeah, and if you go ahead and submit, it will work fine. And this solution takes order of n space, and we can optimize it further. So further optimization goes like this. So we can just take two variables, sum1 and sum2. Sum1 will contain the sum of the array, sum of the all elements of the array, and sum2 contains the sum of the first and natural numbers. So sum1 would be like first and natural numbers, but this missing number would be excluded. So if we subtract sum2 from sum1, we'll get the required answer. So like sum1 will contain, the variable sum1 will contain 1 plus 0 plus 3, which is 4, and the variable sum2 will contain 0 plus 1 plus 2 plus 3, which is 6. So if you subtract sum 2 from sum 1 from sum 2, which is sum 2 minus sum 1, 6 minus 4, it gives 2. In sum 1 equal to 0, sum 2 equal to 0. For int I equal to 0, I is less than nums dot length I plus plus sum 1 plus equal to nums of I, and sum 2 plus equal to I, and sum 2 plus equal to nums dot length, because n should also be added to this, right? Finally return sum 2 minus sum 1. Yeah, you can go ahead and submit this and it will work fine. And there's one more solution which uses the concept of XOR and bit manipulation. It also takes order of n time at an order of one space, but it's kind of a new, like, it's kind of a unique solution. And if this question is asked in an interview and if you tell this kind of solution, it will impress the interviewer, and it will also build your basic concept of XOR. So you can watch this in the next video.